Okay, let's just dive right in. Have you ever wondered what really separates a basic AI chatbot from one that can actually think, plan, and get complex stuff done? Well, the secret is all in the architecture. A Google engineer recently dropped this massive 400-page book on what he calls agentic design patterns. And don't worry, we've boiled down the absolute must-know blueprints for you right here.
And yeah, that's the core idea right there. These 20 patterns are the secret sauce. They're not just theories, they are practical, battle-tested recipes for building AI that can actually solve real-world problems. So think of this as your cheat sheet to the patterns that truly matter.
Now, we're not going to just list all 20 patterns. That would be a nightmare. Instead, we're going to group them into 3 core strategies. This is going to give you a really powerful mental model for how to think about building any advanced AI agent, how it breaks down a huge problem, how it gets new skills, and maybe most importantly, how we make sure we can actually trust it.
All right, let's kick things off with our first strategy, decomposing complexity. This is all about taking a massive, overwhelming goal and chopping it up into small, bite-sized pieces that an AI can actually handle one at a time. You see, the whole idea here is that this step-by-step approach stops the AI from getting lost or just completely overwhelmed. It creates this nice, clear path from A to B to C. And just as important, it lets us build in little checks and balances at each stage, and that's absolutely key for quality control. So, the key pattern to make this all work is called prompt chaining, and the book has this perfect analogy. Think of an assembly line. Each station, or in our case, each prompt, does its one specific job, does a quick quality check, and then passes its finished work down to the next station in line. And you can see exactly how it works right here in this workflow. A request comes in, it gets broken down, an agent starts working, but then, and this for me is the really cool part, we hit step 3, validate. Before anything moves on, the system checks if the output is any good. If it fails, it can try again. If it passes, then it becomes the input for the next agent in the chain, all the way until we get a final, merged result. But, like any design choice, it's not all sunshine and rainbows. There are trade-offs. On the plus side, it's super modular. You can easily swap out steps in that assembly line, and that validation step is great for catching failures early. The downside? It's like a row of dominoes. If one mistake gets through early on, it can knock over the entire chain. Plus, passing all that information from step to step can get really expensive and burn through a ton of tokens. Okay, let's move on to our second strategy. So now our agent can handle a complex workflow. What's next? How do we give it, well, superpowers? How do we connect it to the outside world so it can actually do things, not just think about them? This is the strategy of enhancing capabilities. It's what turns an AI from a closed-off brain in a box into an active player in the digital world. This is how an agent can check today's weather, book you a flight, or search the web, actions that needed to connect to something outside of itself. The key pattern here is called tool use. And the analogy is just perfect. Imagine a chef who needs to make a specific dish. First, they check the pantry to see what ingredients or tools they have. Then they check if they can actually use them. Finally, they grab what they need and put it in the recipe. And you can literally see that chef's process laid out right here. The agent analyzes a request, like, what's the weather in London? And it realizes, hey, I can't answer that on my own. It needs a tool. So it discovers what tools are available, picks the right one, uses it correctly, and then processes the info it gets back. Simple as that. Now, you've probably heard of a related pattern, right? Retrieval Augmented Generation, or RAG. It's pretty simple. Tool use is for doing things, like booking that flight. RAG is for knowing things. It gives the agent a specialized library it can search to answer questions with super specific, accurate info from a source that you trust. So our agent can now break down tasks and use external tools. That's incredibly powerful, but it also introduces a lot of risk. How do we make sure its outputs are accurate, safe, and just reliable? Well, that brings us to our third and final strategy. This is the big one, isn't it? When an AI is running around on its own, we can't just cross our fingers and hope for the best. We have to build in really robust systems for quality control and oversight to catch those errors before they become a real problem. A really fantastic pattern for this is called reflection. The idea is you set up a little team. A generator agent creates a first draft, say an email, and a critic agent immediately reviews it against a checklist of what good looks like. The critic gives feedback, the generator revises, and this little loop just keeps going until the email is perfect.
The source uses this student-teacher analogy, and honestly, it's spot on. The generator agent is the student writing the essay. The critic agent is the teacher with the grading rubric. The essay gets passed back and forth for edits until it finally gets an A+. It's a simple but really powerful loop. Create, critique, repeat. So the benefit here is obvious, right? You get these exceptionally high-quality, polished outputs. But that whole back-and-forth process isn't free. Every single revision is another expensive call to the language model, which adds cost and, of course, makes the whole thing a lot slower. You're basically trading speed and money for top-tier quality.
But what happens when the stakes are just too high, or when the AI runs into some weird new situation it's never seen before? A critic agent isn't going to cut it when you're talking about things like medical advice or moving large amounts of money. For that, you need an even stronger safety measure. And that safeguard is the human-in-the-loop pattern. This is the ultimate safety net. When the system gets to a decision point that's either high risk or it just has low confidence, it slams on the brakes and flags it for a human to look at. A person can then step in, make the final judgment call, and let the agent continue. It's the ultimate failsafe, combining the speed of AI with the wisdom of a human for those decisions that absolutely have to be right. Okay, so we've looked at patterns for breaking down tasks, for giving our agents new skills, and for making sure they're reliable. Let's pull it all together into one simple, powerful framework you can use. Look, the big takeaway here isn't to go and memorize all 20 patterns. It's to get these 3 core strategies locked in your head. First, decompose complexity with things like prompt chaining. Second, enhance capabilities with tool use and RAG. And third, ensure reliability with reflection and, when you need it, a human in the loop. This is your mental blueprint. At the end of the day, these design patterns are so much more than just clever engineering tricks. They are the fundamental recipes for creating AI that has genuine autonomy. They are the blueprints for an AI that can actually think for itself. So the only real question left is, what problem will you solve with it?